You know, every single day, you and we perform a kind of magic, millions of times over, right from our fingertips. We send information clear across the planet in literally the blink of an eye. But have you ever really stopped to wonder how on earth that's even possible?
I mean, seriously, think about it. You click on a video and a server that could be thousands of miles away responds almost instantly. It absolutely feels like magic, but it's not. It's actually one of the most brilliant and robust systems ever designed by humans. So what's the secret sauce?
Well, the secret is right here. It's a part of the internet called the network layer. And the best way to think about it is as the internet's global postal service. Its one and only job is to handle the addressing and the delivery of your data, making sure it gets from your screen to its final destination, no matter where in the world that is.
Okay, so before any package can be sent through the mail, it has to be properly prepared and labeled, right? Well, the exact same thing is true for your data. Let's take a look at how it gets ready for its epic trip across the internet.
Think of it this way. Your data needs to be put in an envelope. It gets wrapped up or encapsulated inside a digital container called an IP packet. And on the front of that packet, we slap a digital shipping label. That's the IP header. And it's got all the crucial info, like the to and from addresses.
This whole shebang is governed by a set of rules called the Internet Protocol, or just IP. It's basically the universal language that every single device on the internet agrees to use for addressing and routing these little packets. Without it, it would just be total chaos online.
Now, to really get why IP makes the internet so incredibly fast and efficient, there are these two core ideas you gotta grasp. And I'll be honest, they might seem a little weird at first, but they are the absolute secret to its success.
First up, IP is connectionless. Okay, so when you mail a letter, you don't call the post office to make sure they're ready for it, right? And you don't call your friend to tell them a letter is on its way. You just drop it in the box and you trust the system. IP works the exact same way. Your computer doesn't set up some special connection, it just fires off the packet and trusts it'll get where it's going.
And the second key idea is that IP is a best effort protocol. Now, this means it doesn't actually guarantee your packet will arrive. I know, that sounds awful, right? But this is the genius of the system. It's a feature, not a bug. By not worrying about guaranteeing every single delivery, IP keeps the network unbelievably fast and efficient. And don't worry, other parts of the system, other protocols, their whole job is to notice if a packet goes missing and just ask for it to be sent again.
So, we've packaged our data, and we kind of get the rules of the road now. But how in the world does the packet know where it's going? Well, it all comes down to a really clever addressing system.
Let's go right back to our postal service analogy. A physical mailing address is hierarchical. You don't just look for Jane's house on a map of the entire world. No, you narrow it down step by step. First, you find the country, then the zip code, then the street, and only then do you find the house number. Each step gets you closer and closer.
And here it is, the big aha moment. An IP address is structured in the exact same way. Just look at this. The first part, the network portion here in blue, that's like the zip code. It gets the packet to the right neighborhood on the internet. And the second part, the host portion in yellow, that's like the specific street address. It pinpoints the exact device in that neighborhood. The simple hierarchical design is what makes routing things across the entire globe even possible.
Okay, deep breath. Our packet is packaged, it's addressed, and it's been dropped into the digital postbox. Now for the fun part. Let's follow it on its incredible journey across the internet.
So here's a really important point. Your computer is not directly connected to every other computer in the world. Of course not. It only knows about its immediate neighbors right there on its local network. So for any address outside of its little bubble, it has one simple job. Pass the packet to the local gateway, which is just your router. Your router is basically the local post office. Its whole job is to handle all the outgoing mail.
And we're off. The packet leaves your computer and arrives at that first router. The router takes a quick peek at the destination IP address in the header, it checks its list of local streets and basically says, nope, this address isn't in my neighborhood, I gotta send this on. So, using its own map of the internet, which is called a routing table, it forwards the packet to the next router that it thinks is in the right general direction. And when the packet gets to that second router, guess what? The exact same thing happens all over again. It checks the address and forwards it along the best path it knows. And this process of a packet hopping from one router to the next, it's repeated over and over and over again.
Each router makes just one tiny independent decision, but when you put them all together, these hops create a path that can guide that packet across continents and under oceans, all in milliseconds. It is an absolutely amazing global relay race.
So after a whole series of these hops, something wonderful happens. A router gets the packet. It looks at the network portion of the address, the zip code, and it recognizes it. It says, hey, I know this zip code. That network is directly connected to me. At that moment, it's like the local mail carrier who knows exactly which house to go to. The long-distance journey is finally over.
Okay, the packet has crossed the entire globe. It's found its local network. Now for the final and most important step, the delivery.
And there it is. The packet arrives safely at the destination computer. The network layer's job is officially done. That IP header, the digital shipping label, is torn off and thrown away. And the precious data that was inside gets passed up to the next system. There, it's reassembled with all the other packets to finally become the complete web page, or video or message you asked for in the first place.
So let's just recap that incredible journey. We took our data, we wrapped it up in an IP packet with a clever hierarchical address, and we sent it on its way. It made a best-effort, connectionless journey, hopping from router to router across the entire world until it found its destination network and was finally delivered. This fundamental process, right here, is what makes our entire modern connected world possible.
But here's a final thought for you. This addressing system we've been talking about, called IPv4, it only has about 4 billion addresses, and we've pretty much run out. So as our world gets more and more connected, with billions more devices coming online, how is the Internet's postal service going to adapt? How will it handle a future with maybe trillions of devices? Well, that's a story for another time. Thanks for joining me.